Mercedes-AMG F1 has been the benchmark until 2022. This team dominated since the new regulations in 2014 when they introduced the hybrid powertrain. Mercedes used additive manufacturing throughout the years to develop the 3D models on the wind tunnel to have the correlation between CFD, wind tunnel and track. In this video I'm going to react how Mercedes used this type of technology to improve their performance on track. For those who doesn't know me, I've been a technical director in Formula Student team and I'm now a CAM designer. So let's jump into the video.
3D printing, but make it F1.
So Robin, we're here in the rapid prototyping department at Mercedes. I'm a bit confused as to what the difference between rapid prototyping is and 3D printing.
So rapid prototyping is the department that we're in. 3D printers are the tools that we use to manufacture wind tunnel models and various other parts.
So we've got
Anthony is a really great driver and the same driver for Mercedes, but obviously is not involved in development of the parts. He only, I think, gives the feedback to the team. Here the engineer or the technician is explaining the rapid prototyping is the type of technology like CNC or mold casting. 3D printers are the actual machines, and also the technology is quite in the early stages, so yeah.
here in front of us, Robin. I mean, what am I looking at here, and do they all come from the same machine?
We have multiple machines and different processes and different materials. This one's an SLA part. It's
SLA part, like we talked about in a previous video, basically it cures the resin into a solid object layer by layer. A scraper will remove the excess resin. I'll do it all over again. We'll create this part with great accuracy.
It's made out of HPC ceramic. Do you want me to come show you the machine?
Oh, that'd be great, yeah. Make a lot more sense to think that way.
This right here is the scraper that I was talking about. It just removes the excess resin on top, so the laser will cure the next one.
This is what we call an SLA machine, stereo lithography. It's a 3D printer that uses light-sensitive resin and a UV laser to turn that liquid into a solid. So what we're doing now, we're building a flat surface, but the actual parts are getting taller by being more submerged into the body of resin.
It's leaving just the top layer that we can see.
Yes, exactly. The working surface is always on the top of the resin.
So how long are we looking at the lead time for the parts it's scanning here?
Okay, so what we're building here is bodywork panels, and I think this is going to run for about 80 hours.
80 hours. Just quickly pause the video and let me know if 80 hours is too much for a part. 80 hours for the panels, so I suspect this is for the wind tunnel model. One of the perks of this type of technology is you have the whole build plate, and one part or two parts or 100 parts will take roughly the same. 80 hours for a bunch of parts, maybe it's not that much.
80 hours?
80 hours might be a long time for one part, but what we're building here is a collective part. You know, we're building maybe like 25 large panels.
Okay.
And if you wanted to build small, intricate parts, you could build maybe 100, 150, depending on the size of them.
It's making a lot more sense.
About 2 months ago, I was in an air show when they have 3D printers, and they were developing parts from literally a 3D printer to post-processing, painting, and to an aircraft. Of course, it needs to have some certification because of the materials, but they printed this kind of panels, and then something like these things right here, just toys for the kids. So
this is a MultiJet printer. This is the only machine in the department that can run dual materials within the same job.
How does it achieve that?
So these cartridges you see on the front, there's Elastico, which is a soft material, and you've got Vero, which is a stiff material. As they put each layer down, say half of it will be stiff white and half of it will be flexible black, but they're built into the same component. Each layer is built into and on top of.
This type of technology is so clever because when you design a part, a stress part, it have to withstand some loads, like an upright for the suspension or a wheel hub. The spot they want the more flexible material, the more tough material. There's less waste material, and they get the properties of the part just right.
The next one,
It
so
makes sense,
it's integrated into the part.
I never realised exactly the purpose of rapid prototyping and where those parts necessarily came from on the wind tunnels. As anything in Formula One, there's always more than meets the eye.
There always more than meets the eye at first, because F1 is like one of the top, if not the top, competition in technology and development. The most 3D printed parts are a prototype. The wind tunnel model needs to have a material, usually in a SLA, because the precision is much greater than the other type of printers. The material for the wind tunnel is usually very hard, so it will not deflect under the loads when they running aero tests. So right now I'm developing a land speed 3D printing card, trying to break a World Guinness record probably, and I'll make a video about it. The other two cool projects that I have will be with 3D scanning. I'll try to make like some type of wing for my car, align with that with the carbon fiber. I have some carbon fiber to make some parts with the SLA printer. If you enjoyed this type of content and projects, don't forget to leave a like and subscribe, and tell me if you have ideas for another cool project. For now, that is all. Thank you very much for watching. Take care.